Hello students, welcome to Board Maths Made Easy. In yesterday's class, we saw the part 1 of the real number system where we learned Euclid's division algorithm and what are the prime numbers, what are the composite numbers. In today's class, we are going to learn fundamental theorem of arithmetic and also in depth, a little bit more in depth, prime factorization method. Later on, we will learn the highest common factor method, okay, how to find the HCF and least common multiple in this session. First, let us understand what fundamental theorem of arithmetic says. Every composite number, we know what exactly composite numbers, that means they have factors more than 2. So such numbers can be expressed as a product of primes and factorization is unique irrespective of order of those numbers. Okay. We have done few examples also yesterday. So the same examples or similar examples we are going to try a little bit more. In yesterday, we learnt few numbers like 5005, 7429, etc. numbers. We have tried to factorize it. I think we have done even 140, correct? So now, what exactly this fundamental theorem says that any composite number can be expressed as a product of primes like 4 into 7 into etc., but 4 is actually not a prime, but it can be represented as a power of a prime like 2 square. So similarly here we can write any composite number as product of primes and factorization whether is unique, that means whether you write 2 square or 4 both are one and same, but as 4 is not prime we should convert that into a prime number like a 2 square here in this case. Okay, similarly anything that we are writing in prime numbers and their product and their powers, such number, if it is a composite number, these will be useful when we go to find the highest common factor or least common multiple, that we will see in the later section. Okay, so now here we have an example. 12 is equal to, we know it, 12, any number ending with a 2 is divisible by 2. So 2 into 6, and we know 6 can be written as 2 into 2 into 3. While writing it in the power format, I always take the least possible number as first, and then if it is multiple places present in the product, how many times it is present? Here it is 2 times. It's a 2 to the power 2. Of course, why 2 to the power 2? We call it as simply 2 square. But if it is more than 2, 3, then we don't have a specific name. So then we will say 2 power 4, 2 power 5 like that into 3. So this is same represented in this manner. Similarly 18. 18 it is ending with 8. 2, 0, 2, 4, 6, 8. We can multiply. Okay, we can use 2 as a factor, then 9. So for 9 we know only 3 into 3, so this is 2 into 3 square. We can write similar factors. Yesterday we have done this exercise, so it is just the definition and how we are writing more examples. So that is clear. So we are writing as a product of primes, so that is called as prime factorization method. Simply that means you are making it as a product of primes. So give a number, divide the number by the smallest prime number, whatever the small, yet we know if not the entire list of the prime numbers, there is no limit on the prime number list. They will start with the 2 because 1 is not a prime. So 2, 3, 5, 7, what else? 9, no. 10, no. 11, 13, then 17, then 19, and so on. So these are the primes. So if you are starting with the least possible prime, why we have the division rules? They will help us at least with the first of few prime numbers. If a given composite number, let us say it will start with 17 into 23, that is the least possible prime factors possible for a given number, then in that case all the division rules are they going to really help you? Definitely not, but you need to know other methodologies. Like suppose if a number is ending with I will tell you the small trick here, that once I complete these five factorization method steps, then I will come back to that trick. Divide the number by the smallest prime number, whether it is divisible by 2, 3, 5, 7, 11. You can figure out using our rule box. Next, continue dividing by prime factors. Like here, first you divide with first prime, then get the next value, then again make it into prime factors and keep continuing. So write the product as a prime factors in the unique until you cannot divide it further with any number. Or when the quotient becomes, suppose you reach a stage where 7 is left out, okay, after doing some 2 into 3 into 5 into 7 is left, and when you do division with 7, the quotient got 1. That means you cannot further divide it, right? That means 7 1 7, that's it. So the remainder become then 0. That means there is no further division required. So until that point you have to start doing the factorization. Once that is done, what you do, write the number as a product of powers of prime factors like this: 2 into 3 into 5 into 7. If there is a repetition of 5 twice, then you will write it as 2 into 3 into 5 square into 7. Is that clear? So this is the methodology how you can do prime factorization for any given composite number. Now, a small technique. Even though we have the division rules, sometimes the easiest way is, suppose a number is there which is ending with 1. We know that either 1 into 1 will give this last digit 1, or 7 into 3 or 3 into 7. These are the only possibles. Similarly, if there is a number ending with 4, either say 4. 4 means 1 into 4 or 2 into 2 should be the last two multiplication factors, right? Similarly, that means if there is a 14, either it could be something into 4 ending with 4, that means 1 into 14, or it could be 2 into 7. See, here 2 is there, or here 2 into 7 ending number. These will only give the last digit 4. Similarly, if there is a number ending with 2, I can't write everything here, but I will try to explain. So if a number is ending, like say something something ending with 2, so it should be 1 into 2, or it could be 3 into 4, or it could be 7 into 6. Correct? So one of those numbers ending should be 7, and the other number should be ending with 6. In that case, 7 6 42, 2 will come at the end. But what is the remaining number? It depends on. So based on that value, we have to see whether we can use, like suppose if some number is given ending with 9. Ending with 9 means either it should be some kind of product ending with the two numbers whose last two digits are 3 into 3 and 3, or 1 into 9, or 7 into 7, because 7 into 7 also gives the last digit as 9, 49. So the 4 may be added to the left numbers. That is the reason. Based on that, whether this is an approximation of, see, instead of 10 digits, you can use only 2 or 3 digits, which can give you an approximate idea. Suppose if there is a number called 670, so it is, we know that the product will be more than 25 into 25. That means 25 into 25 is 625. So that may be another 50 addition. That means 25 into how much? Okay, so you need to see that whether I will add 625 plus another 50 will add 675. So 675 means it is 25 into 27. If it is a 670, that is a fraction. So that means there will be change in the numbers. Okay, so we need to see, like 670 means it is ending with 0, means either 0 or 5, or already we know 5 is there, so 10 also there. So 10, always remember 10 can be written as 2 into 5 as a prime factors. Okay, so this is how you can solve factorization. If there are any number of things given, try to use this smart logic so that you don't need to struggle what number can divide or what number should be ending. Try to do some small approximation rough work and you will try to figure out easily. Okay, the next part is the highest common factor finding. If there are two numbers given to you, like say here I just took 12 and 18. Okay, we can take any number, but I'm just taking for our simplicity 12 and 18. What is the highest common factor? See, remember here the highest common factor means the number that can divide both 12 and 18. Remember this. Highest common factor is the highest value which can divide each value we consider to find the highest common factor. How can I consider those factors? You cannot consider, you will find out. So for 12 and 18, you need to find out the highest common factor. How can I do this? Now, to do that, there is a defined process, that is product of the smallest powers of common prime factors. So first of anything, you need to find the common prime factors. Here in this case 12, for 12 I want to find out. Okay, I will find 12 is equal to 2 into 6, 2 into 2 into 3, that is already we found in the above also. So I will use 2 square into 3. In case of 18, I can write it 2 into 9, 9 is 3 into 3, that is 2 into 3 square. Remember, as we are not doing exercise here, okay, we are directly writing the steps, but when we come to the exercises, we will write step by step. Okay, here I am writing step by step, but it is not like a clean step by step, but we'll do it. So here 12 is 2 square into 3, 18 is 2 into 3 square. What he is mentioning here, product of the smallest power of common prime factors. What is common in this one? 2 is common, 3 is common here. Here in this also 2 and 3 are common. But what is the power of this one here? It is 2 square. Here it is 3 square. But whenever you are finding the highest common factor, you need to consider only the smallest power of common prime factors. Remember, if there is a number which has another prime factor, say 5, is this common in both? No. So this is not qualified. Only the numbers which are present in both, they will be common factors, and their powers. If there are two different powers in two different numbers, you should take the least one. That means here we will take here we will take only this, because they both have the powers as only one. That means 2 into 3. See, their product you need to take. You take the smallest power of common prime factors and their product. So in this case, 2 into 3 gives the HCF, that is 6. So if you remember this definition, highest common factor is the highest value which can divide each value we consider to find the HCF. What we considered here to find the HCF? 12 and 18. For 12 and 18 only, we are finding the highest common factor. And that highest common factor value can divide each value. That means, can 6 divide 12 and 18? 12 by 6 is possible? Yes. And 18 by 6 is possible? Yes. So highest common factor is a value which can divide all the given values for which we found the HCF. So remember this. Suppose A, B, C, D, 4 numbers are given to you. HCF will be always in the denominator, which can divide independently each value independently. That means A by HCF is possible, B by HCF is possible, C by HCF is possible, D by HCF is possible. Not the way around. That means not like HCF by A, not like HCF by B. No. HCF will be always in the denominator, which can divide each input given value. Okay, when it comes to the LCM, we will see it slightly different. Okay, so if HCF is clear, the concept, we will proceed to the next one. And also remember, HCF is the highest common factor. This is not a definition, but you can say this as the definition. Honestly, whenever they are asking what is the HCF means, product of the smallest common prime factors, product of the smallest powers of the common prime factors. Okay, that is highest. But in reality, HCF can divide each input value with the remainder 0. Okay, next let's proceed to the LCM. Remember, before proceeding to LCM, a small tip. HCF is always lower than the given values most often because we have to divide the given value, right? Like suppose 12 is one input value that we need to divide integral division. So that is possible only when the HCF value is smaller than the given values. In case of LCM, LCM is product of the greatest powers of all prime factors. Remember here the difference, product of the greatest powers of all prime factors. Here powers of common prime factors. Here we are looking for the common. If the factor is commonly present in both the numbers, then we will consider. In case of LCM, we don't look for the any factor which is common or not. We will look each factor independently. That means even if it is not present in another number, we will consider it. Okay, here in the HCF, if you recall, we discarded 5 because it is not present in both the numbers. But in case of LCM, we will consider both those factors. Okay, so product of the greatest powers. Here in the HCF, we have taken the least powers of the common prime factors. But in the LCM, we take the greatest powers of the prime factors, not the common prime factors. Remember that, okay? So I written here, remember, take the greatest power of each prime factor. The factor need not be common. Okay, so I will try to upload this PDF into my videos. So don't worry, you can take that notes later on, but first try to understand the concept. So now I took an example like why I have taken quick examples means when we come to the exercise we will directly solve the problems. Here with examples you will try to observe the concept faster. That is the only reason I have taken the example. So 60 we know it 2 into 30 and 2 into 30, obviously we know that it is 0 or 5, we can divide with 5. If it is 0, we can divide with 10. But I would prefer to do it one by one. 2 into 15 and 2 into 2 into 15 is 3 into 5. Here what are the products of these prime factors? 2 square into 3 into 5. Similarly, if you take 18, what 18 actually is, we know it, 2 into 9, that is 2 into 3 into 3, 2 into 3 square. If you recall here, product of the greatest powers, here greatest power, here is 2 present, here is 2 present. What you do first, list out all the factors. 2 is present here, okay, 3 is present, 5 here only present. Is there anything additional factors? No. So what is the greatest power of in these 2 square? What is the greatest power in these two? 3 square. What is the greatest power of 5? Only 1. So you take the product of the greatest power of all prime factors, not common. Remember, again I am saying in the HCF we use the smallest power of common prime factors. In LCM we take the greatest powers of all the prime factors. Okay, so this is 2 square is 4 into 9, 4 into 9 into 5. So it gives us 180. Is that correct? So earlier HCF can divide each independent value. If you remember, HCF can divide 12, HCF can divide 18. But in the case of LCM, LCM can be divided by the given numbers. Like here we found the LCM for 60 and LCM for 18, correct? So each individual can divide LCM independently, giving 0 remainder. Okay, it gives the remainder 0. And similarly, what we'll say, LCM divided by 18 also give 0. Why? It's not quotient I'm talking about only the remainder. LCM is 180. 180 divided by 60. What it will give? 3. Remainder 0. LCM 180 divided by what is the other number? 18. So 18 gives 180 by 18 gives quotient 10 and remainder 0. So in case of HCF, each individual value will be divided by HCF giving 0 remainder. in case of LCM, when you find the LCM, okay, what actually LCM? Least common multiple. That is the purpose of that. That means it is a multiple of the least common values. Okay, don't get confused with this terminology. But least common multiple means these two can divide the value. Okay, the LCM value 180 by 60 3 and 180 by 18 10. And while finding the LCM, how to, I am getting confused. Okay, don't say that word. The easiest trick is, whenever you are finding the highest common factor, you will take the least powers of the common factors. Remember this word, least powers of the common factor. Okay, and their product is the HCF. Product of the least powers of the common factors gives you HCF. In case of LCM, here the name is least common multiple, but you will find the greatest powers of the prime factors alone, not the common prime factors. In the HCF is common, in the LCM just prime factors, the greatest powers of the prime factors, their product is the LCM. I hope if you know these two rules, okay, you will definitely get a question, and there is some dependency problem also we will get. Okay, remember these topics you don't find everywhere, but I'm giving you extra point. LCM does not directly depend on Euclid's division algorithm. Why? Okay, we will see why, if it is required, but it is not in your scope. If at all you get a 1 mark question, you can say LCM does not directly depend. HCF will directly depend, because in highest common factor you are finding the common, here you are using common prime factors. That is the reason. In case of least common multiple, even though the word common is there, the prime factors are not common. Okay, that is the reason LCM does not depend directly on the division algorithm. And there is one thumb rule. If you find both HCF and LCM, LCM and HCF into HCF will always be equal to the product of the given numbers. Like suppose if a product is if we found LCM and HCF for 18 and 12, then LCM into of 18 comma 12 into HCF of 18 comma 12 is equal to 18 into 12. See here, HCF of 12 comma 18 is 6. Okay, HCF is 6. And what is LCM? If you remember, the highest prime factors product, 2 square into 3 square, correct? So LCM is equal to 2 square into 3 square. 2 square is 4, 9, 3 square is 9, 4 into 9 is LCM is 36. So in this case LCM is 36 and SF is 6. So this gives 216 is equal to, is 12 into 18 same? Of course, if you take this split 12 as a 2 into 6, so 6 into 2 into 18, that is again 6 into 36. That means you are sure that LCM into HCF is always equal to 18 into 12. What kind of questions we get in general in our board exams is, they will give you either LCM or HCF and other product or the numbers, or otherwise they will give you LCM, HCF and one number and ask find the next number. So this is the methodology we have to, this is the formula, only single formula, LCM into HCF is equal to product of the numbers. This is applicable only for when you are finding the LCM or HCF for only two numbers. If there is like 3 number system, like you have 12, 18 and some other 24 is there, now you need to find the LCM. Okay, you need to find same way, like you need to find the, here we have done right, like we have found the HCF for 12 comma 18. Similarly, if there is a 12 comma 18 comma, let me say this way, so there is a 12, 18 and 54 is given, they are asking for finding the HCF. You know it, 12 comma 18 is 6 into 2 comma 6 into 3 and then 6 into 9. Okay, here I mean, I'm just straight away writing, but you need to find the 54 factors. 54 factors is equal to 2 into 27. That is 2 into 3 into 3 3 is 3 cube, correct? Okay. So greatest factors, we know 2 square into 3, 2 into 3 square. Now we know 2 into 3 cube. So product of the greatest common prime factors when you are finding the HCF, 2 square into 3 square into 2 square into 3 square into 3 or 3 cube. The greatest factor is 3 cube. So 27 into 4. 27 into 4 is 108. So 108 is the, oh, 1 second. HCF is the highest value which can be sorry, it's my mistake, my bad. HCF is always least powers we need to take, sorry, that's my bad. Okay, so it is 2 into 3 only. 2 into 3 is again 6. HCF is the same as 2 into 3, that is 6. Okay, because HCF should be able to divide all the given numbers. Okay, if you are studying, carefully take time and ensure that you are not doing mistake like me. Okay, because in the as I am trying to think through the next topic, those are getting into discussion. Whereas LCM, greatest factors, okay, need not be common. So here 2 square, LCM is equal to 2 square into 3 cube. In this case 4 into 27, 108. So 108, see, LCM can be divided by all 12 and 18 and 54. All of them can divide this. Okay, when you do the division, you should be able to get the integer again as a result with the remainder 0. So this is about finding the LCM and HCF. And we already learned one more thing. LCM and HCF is equal to product of the given numbers. So in case of 3 numbers given, you need to find the LCM of 3 numbers. And in case of HCF, you need to find the HCF of 3 numbers. So if they have given LCM and HCF of 3 numbers, and now they gave only 2 numbers, so how can I, you don't get the 3 number systems usually. At the maximum they may ask you LCM of 3 numbers and HCF of 3 numbers. This rule is not applicable for, remember, this rule is not applicable for 3 number system. Okay, it is applicable only when there are 2 numbers given like this. Need not be like this, any number, any 2 numbers. So for that we have a separate formula which is not in our scope. Okay, don't get worried about all those not present things. So that's all for this video. Next video we will go through proving the irrationality of numbers. Once that is also covered, the concept part will be done. Then we will take exercise one by one and we will try to solve each and every problem. That's all for the day. Thank you.